We have LHS as sin A minus 2 sin cube A, that divided by 2 cos cube A minus cos A. Now taking sin A as common from the numerator, we get 1 minus 2 sin square A, and taking cos A as common, we get 2 cos square A minus 1. Now sin A by cos A can be written as tan A, and then we are going to write sin square A as 1 minus cos square A, that divided by 2 times cos square A minus 1. Now opening the bracket, we get 1 minus 2 plus 2 times cos square A, that whole divided by 2 cos square A minus 1. This is tan A. On simplifying this, 1 minus 2 is what? Minus 1. So first we'll write 2 cos square A minus 1, that whole divided by 2 cos square A minus 1. So 2 cos square A minus 1, 2 cos square A get cancelled. That results to give tan A, and that is equal to the RHS. We have RHS as secant theta plus tan theta, the whole square. Now we can write secant as 1 by cos theta and tan as sin theta by cos theta, that whole square. Now taking cos as LCM, we get 1 minus sin theta over cos theta, and then the whole square. Now separating their square, we can write 1 minus sin whole square divided by cos square theta. So 1 minus sin whole square can be written as 1 minus sin into 1 minus sin, and cos square theta can be written as what? 1 minus sin square theta. Keeping the numerator as same and applying the identity, we can write 1 minus sin square as 1 minus sin into 1 plus sin theta. So here 1 minus sin and 1 minus sin get cancelled. That results to give 1 minus sin theta over 1 plus sin theta. And that we have secant A plus tan A, that multiplied by 1 minus sin A. Now what we can write secant as 1 by cos A, and similarly we can write this tan A as sin A by cos A, and that whole multiplied by 1 minus sin A. Now taking cos A as the LCM, we get 1 plus sin A, that divided by cos A, and this is 1 minus sin A. Now what is 1 plus sin into 1 minus sin? That is 1 minus sin square A, that divided by cos A. So we know that 1 minus sin square A is cos square A, that whole divided by cos A. So here 1 cos get cancelled, that results to give cos A. Therefore option B is correct. We have cosec theta minus cot theta, the whole square. So we can write cosec as what? 1 over sin theta, and cot as cos theta over sin theta, the whole square. Now taking sin theta as LCM, we get this as 1 minus cos theta and the whole square. Now separating the square, it is 1 minus cos theta the whole square, that divided by sin square theta. Now we can write 1 minus cos theta whole square as 1 minus cos theta into 1 minus cos theta, and sin square theta can be written as 1 minus cos square theta. So keeping the numerator same, we can write, applying the identity of a square minus b square, it is 1 minus cos theta into 1 plus cos theta. So now 1 minus cos theta get cancelled over here. So that results to give 1 minus cos theta divided by 1 plus cos theta. Option B is correct. We have LHS as secant minus tan over secant theta plus tan theta. Now we can write secant as what? 1 by cos, and tan as sin by cos. Now so we will do in the denominator. So that is 1 by cos plus sin theta by cos theta. Now taking cos theta as LCM, we get 1 minus sin over cos theta. And so in the denominator, that is 1 plus sin theta over cos theta. Now here cos and cos get cancelled. That results to give 1 minus sin over 1 plus sin. Now since we need 1 plus sin, so we'll be multiplying, dividing by 1 plus sin. So it results to give 1 minus sine into 1 plus sine is 1 minus sine square theta, and that divided by 1 plus sine theta the whole square. We know that 1 minus sine square is cos square, so this is cos square over 1 plus sine theta the whole square, and that is equal to the RHS. Question is, prove that secant minus 1 over secant plus 1 equals sine square theta over 1 plus cos square theta. Now we have LHS equals secant theta minus 1 over secant theta plus 1. Now we can write secant as 1 by cos, so it is 1 by cos theta minus 1, and similarly it is 1 over cos theta plus 1. Now taking LCM, we get 1 minus cos theta, that divided by cos theta, and then whole divided by 1 plus cos theta over cos theta. Now here cos and cos get cancelled, so that results to give 1 minus cos theta over 1 plus cos theta. This is 1 plus cos theta. Now since we need sine square in the numerator, we will multiply divide by 1 plus cos theta. So this is 1 minus cos into 1 plus cos is 1 minus cos square theta, and this is 1 plus cos theta the whole square. Now 1 minus cos square is sine square theta, that whole divided by 1 plus cos square theta, and that is equal to the RHS. In this question, we have to prove that 1 minus tan square theta over 1 plus tan square theta equals cos square theta minus sine square theta. Here we have LHS as 1 minus tan square theta over 1 plus tan square theta. Now we are going to write tan as sine by cos. So it is sine square theta by cos square theta in the numerator, and denominator this is 1 plus sine square theta over cos square theta. Now we are going to simplify by taking LCM here. So it is cos square theta minus sine square theta over cos square theta. That whole divided by, same here, this is cos square theta plus sine square theta, and that divided by cos square theta. Now cos square and cos square get cancelled. That results to give what? Cos square minus sine square in the numerator, and that divided by, we know that cos square plus sine square or sine square plus cos square is 1. So that is divided by 1, that is equal to RHS. In this question, we have to prove that tan over secant minus 1 plus tan over secant plus 1 is equal to 2 cosec theta. Now we have LHS as tan theta over secant theta minus 1 plus tan theta over secant theta plus 1. So first thing we will do is to take tan theta as common. That results to give 1 over secant minus 1 plus 1 over secant plus 1. Next we are going to take a LCM inside, that is secant minus 1 multiplied by secant plus 1. And 1 multiplied by secant plus 1 is secant plus 1, and similarly this is secant minus 1. So 1 and minus 1 get cancelled, so that results to give 2 times secant theta over, and a minus b into a plus b is what? A square minus b square. So we get this as secant square minus 1. We know that secant square minus tan square is 1, therefore secant square minus 1 can be written as tan square theta. Now 1 tan get cancelled, so we get this as 2 secant theta over tan theta. Now secant theta can be written as what? 1 by cos. So we'll write this as 2 over cos. And tan theta is what? Sin theta by cos theta. So dividing by sin by cos is same as multiplying by cos by sin. So cos and cos get cancelled. So we get 2 times 1 over sin, and 1 over sin theta is cosec theta. So we'll write 2 cosec theta, which is equal to RHS. If secant theta plus tan theta equals x, find the value of secant theta. We know that secant square minus tan square theta equals 1. Now applying the identity, we can write as secant theta plus tan theta multiplied by secant theta minus tan theta, and that is equal to 1. Now substituting secant plus tan as x, we get x times secant minus tan theta, which is equal to x. Now transposing x to the other side, we get secant theta minus tan theta as 1 over x. So now copying this, secant theta plus tan theta equals x. And on adding these two equations, we see that tan theta and minus tan theta get cancelled. So that results to give 2 times secant theta, which is equal to 1 over x plus x. Now, so we get 2 secant theta is equal to taking LCM as x, we get this as 1 plus x square. Now transposing 2 to the other side, we'll get secant theta is equal to 1 plus x square over 2x.